I skip. No, wait. That's important. Okay. In this star example, we had one star with two properties, and we were comparing the two properties, which means we had the same number of B values and V values, and they were belonging to one star always. But let's say you have one catalog of B magnitudes and one catalog of V magnitudes, then entry number 1 and entry number 1 do not correspond to the same star necessarily. It's very unlikely that the two catalogs have the same size, and so on. Yeah? So these might be independent data. Very often you have independent mean values that you would like to compare with each other. That's done here in the next example. You recall the data set county text from the second example or so, where we had kind of statistics from US American counties, income statistics, population gain, and so on. And we were in one part of the problem splitting the data into county gained population and county didn't gain population. So we were splitting that. It was a not equal number of counties, and then we were doing separate statistics. That's the population gained, median income histogram, and that's the no population gained. And these were the numbers that, in a sample of 300 counties. Yeah. And now we would like to quantitatively answer the question, is there a difference in median income per household between these two classes of counties? Yeah? So it's the mean value of counties that gained minus not gained, is it 0 or not? Our point estimate is from the table before. And we are estimating here the difference between independent means. And that's computed like this. So we are taking the difference between the mean value and not, like in the paired example, the mean value on the differences, plus minus the critical, and then the standard error of this difference. And the standard error of this difference is computed like this. So we take the sum of two standard deviations squared over the size of these two samples, and then take the square root for the standard error. We have this. So when we test here the independence, then now we have to be careful, because you have to test within groups, within the group of population gained, within the group of not gained, and we have the independence between the two groups to test. Yeah, so both must be independent of each other. Okay. So this is the confidence interval that we compute. The numbers we got from the table, and that means we are 95% confident that the difference between median income of counties that gained and didn't is somewhere between these two numbers. For our hypothesis tests, again, we set up the null hypothesis, where we're saying, okay, that's 0. The alternative is not 0. And then we can draw the distribution, basically. This is our distribution that we are looking at. The mean value is 0, set again by the null hypothesis. And the standard error is this. That we computed before. our test statistics is here C of 5.6, and we are testing a two-sided test because we are asking, no, it's not 0. So we are asking, it's either larger than this or smaller than this, and the p-value for this is also 0. Yeah, so we are 6 standard deviations away from the mean, so that's 0.